Hey guys, this next example is all about using Bayes' theorem. It's a pretty challenging example and it's in your homework. So hopefully this will give you a good strategy on how to get through the Bayes' theorem problems in your homework, on the quiz, and on the exams. Pause the video and read through the problem description. Okay, just like every other problem we do, we just first want to pull out the information that they give us in the problem. I also want to show, I just kind of created some shorthand. So lowercase I means the data entry was incorrect, the requisition was incorrect. Lowercase I means the requisition was incorrectly entered, so I incorrect. A 1 indicates that specialist 1 did the requisition to specialist 2, 3, and so forth. Okay, just so it'll save some writing for us. That's what those mean. Now let's identify the numbers. Specialist 1 processes 68% of the requisitions. We can pull that out and say the probability that specialist 1, okay, using a 1 for specialist 1, the probability that he or she does a requisition is 0.68. Specialist 2 does 16%. And specialist 3, 16% as well. Okay, moving on to the next sentence is proportion of incorrectly entered requisitions. What does that mean in probability statement form? Okay, let's just start with specialist 1, and the percentage that they give us for specialist 1 is 0.02. Let's put that into a probability statement. So the proportion, or the probability, of incorrect requisitions by specialist 1, given that specialist 1 entered these requisitions, what's the probability or the proportion that it was entered incorrectly? 0.02. Okay. Not so hard. Moving on, same thought process. The proportion of incorrect data entries given that specialist 2 entered them is the 0.06. And last, the probability of an incorrect data requisition by specialist 3, 0.02. Okay, that's just the setup. Make sure that you understand how we pulled these numbers from the problem into these probability statements, because that is going to be key before we can even tackle this probability statement here, which is what the question's asking for. Suppose a random requisition is found to have been incorrectly entered. So given it was incorrectly entered, what's the probability it was processed by specialist 1? We'll start with this one. I'm just going to rewrite this into my shortened notation. The probability of 1 given I. This is different from this. Look at your probability rules handout that I emailed out earlier this week. To compute a conditional probability, there's a simple just conversion formula. This is equivalent to probability of 1 and I over the probability of the given information, the information that has already occurred. Let's take a look at this top piece. This is going to be a little bit easier to calculate, but notice that we don't have either of these pieces that we need for the formula. So we're going to have to construct those. I copied and pasted the general multiplication rule for any events. This is also on your probability rules handout, but it's just easier to refer to here. If we want to compute a joint probability, we can do that in both of these ways. Maybe pause the video, take a second, and think about which pieces we have using this formula to calculate the probability of 1 and I. We have the probability of specialist 1, and we also have the probability of it being incorrect given specialist 1 computed it. I just use this formula down here with the notation that we're using based on this problem. Now I'm just going to fill in the pieces what they actually are. Probability of 1 is the 0.68. Probability of I given 1. Multiply those two together. There we go. We have our numerator. Goes there. We need this denominator. What's the general probability that a requisition is incorrectly entered? Now let's think about this. The probability of something being incorrectly entered, just in general. No given information. This can happen three ways, so think through this logically with me. Something can be incorrectly entered by specialist 1, or it could be incorrectly entered by specialist 2 or specialist 3. So those are the three ways something can be incorrectly entered. Okay? So one of the specialists has to input it, and it has to be incorrect. That's why those are joint probabilities I and 1. Let's do some simplification. These ORs, these union symbols, translate to addition. That's simple. We already looked at the joint probability of I and 1. We didn't have it explicitly given in the problem. We had to create it right here. Okay? Again, the order around the joint symbol doesn't matter. It could be 1 and I or I and 1. Okay, so we already have this piece. This one is equivalent to the probability of 1 times the probability of I given 1. We can use that same thought process for the rest of these pieces. Probability of I and 2 is the probability of 2 times the probability of I given 2, plus probability of specialist 3 multiplied times the probability that incorrect given specialist 3 entered it. All of these pieces we have organized at the top of the problem, so it's simple to plug in. Okay, multiply and add this through, and we get 0.0264. This is our number for the denominator. This is the probability of an incorrect data entry in general. Let's finish this out and just plug our pieces in. Equals, that's the probability that specialist 1 did the data requisition given that it was found incorrect.